Thanks for joining me again here at Math Rocks with Mr. Cox. This video is going to be about reversing what we've done in the past, which is multiplying polynomials. So you learned about a method called the area model, where you would take x plus 3 and put it along the side here, and the other trinomial here, you would put x squared minus 2x plus 4 here, and then you'd start multiplying them together. So for instance, x times x squared is x to the third, 3 times x squared is 3x squared, and you just keep doing that. And then you combine like terms here in the middle and come out with an answer like this: x to the third plus x squared minus 2x plus 12. So that's multiplying polynomials together with an area model. And this video is about actually doing the reverse. We're going to be doing, instead of multiplying, we're going to be doing division. So stick around, see how that works. Let's get it on! Let's go ahead now and see how polynomial division works using an area model. You'll notice here, once again, we have the model all set up, ready to go. We're going to take this x plus 5, and we're going to put it along the outside over here on the left. And we're trying to figure out what multiplies times x plus 5 to give us this answer of 2x to the third plus 13x squared plus 14x minus 5. So here's what we know. We know that when we combine all 6 squares on the inside here, it should add up to be what I'm underlining here in blue. So I'm going to go ahead and I'm going to put this 2x to the third right over here. And what we're going to do is we're going to say, well, what multiplies by x to give us 2x to the third? Well, that would be 2x squared. So that's going to go up here, and that's going to be part of our answer. And then we're going to multiply 5 times 2x squared to give us this little box right here. Now combined, we're going to need a total of 13x squared. We already have 10x squared inside the box, so I know that I'm going to need 3 more x squared right here to add up to be our 13x squared. And then we do the same thing we were doing earlier. X times what gives us 3x squared? Well, that would be 3x. And then I'm going to say 3x times 5 is 15x. And we're almost there. I know I'm going to need 14x altogether. I've already got 15, which means I'm going to need a minus 1x right over here, because combined, these two add up to be 14x. Then I say x times what is negative 1x? Well, that will be a minus 1. And then I'm going to say 5 times negative 1 is negative 5. And lo and behold, that is our last term here. So our answer is 2x squared plus 3x minus 1. That would be how many times x plus 5 divides into it. Now, is it a factor? Is x plus 5 a factor? And the answer is yes, and it's really a very simple reason. There is no remainder. We needed a negative 5 at the end, we got a negative 5. So is it a factor? Yes, because we have a remainder of 0 in this case here. And that just goes back to basic math. Why is 5 a factor of 10? Because 5 goes evenly into 10 with a remainder of 0, whereas 7 doesn't. So that's how you know something is a factor, if the remainder when you're all done is 0. Let's go ahead now and take a look at a second example. In this example, we're going to see if x minus 2 will divide evenly into x to the fourth plus 2x to the third, etc. here. So let's go ahead and set up our area model so we're ready to go here. I'm going to go ahead and put an x minus 2 right over here. And then, let's see, we need x to the fourth to be part of all the little squares or all little rectangles inside here. So I'm going to go ahead and put an x to the fourth right here. And working backwards, I say x times what gives me x to the fourth? Well, that'll be x to the third. Then I take my x to the third, multiply it by negative 2, I get negative 2x to the third. Now altogether I'm going to need a positive 2x to the third, so to get there I'm going to have to add on 4 more x to the thirds, because these two combined will give me my 2x to the third. So x times what is 4x to the third? Well, that'll be 4x squared. I go ahead and multiply that 4x squared times negative 2, I get negative 8x squared. All right, looking at the negative 8x squared here, well, what do you notice? I already have negative 8x squared, and I'm going to need negative 8x squared. So really, I don't need any more x squareds, but I need to put something down here, so I'm going to put 0x squared. So x times what gives me this? Well, that'll be a 0x. 0x times negative 2 is going to be basically 0x. Okay? At this point, I need 5x altogether. And you'll notice here I already have a 0x, so that means I'm going to have to put a 5x right over here. And x times what gives me 5x? Well, that'll be a plus 5. And then we have 5 times negative 2 is going to be negative 10. All right, now at this time you'll notice this negative 10 is not the same as our remaining last constant here on the end. They're different. And to get from negative 10 to positive 2, I'm going to have to add on 12. So that is what we call our remainder. So when we say, hey, is this actually a factor? We would say no, and the reason is simply our remainder is not 0. We actually have 12 left over to get from negative 10 to positive 2. And our answer, if we were going to write this out, is going to look like this. We're going to say x to the third. We have a 4x squared. We don't have any x's, which is okay, so we're just not going to write them. We do, however, have a plus 5, and because we have a remainder of 12, we're going to say plus 12 over what we were dividing into, x minus 2. So what I've written here in red would be our technical answer for what it would be if we divide x minus 2 into this entire one big happy polynomial here. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. All right, so the last thing I want to show you is there is another way. In fact, there's actually other ways of how to do division. This is the one I happen to like the most. It's called synthetic division. And it's going to wind up getting us the same answers, just done a little differently. And I feel compelled to show this to you. So if this is, we're checking to see if that's an actual factor. If we said this is a factor, that means the root in this case would be negative 5. X equals negative 5 would be our root if that were true. And so what we're going to do is we're going to take what that root would be, negative 5. I'm going to put it out here in a little like half box. And I'm just going to write all the coefficients here that you see. So I see a 2, I see a 13, I see a 14, and I also see a negative 5. And so I'll show you how this synthetic division works here. First of all, whatever the leading coefficient is 2, you just carry it down, so there's a 2. And now here's how it works. I take my negative 5, multiply it by that 2, and I get negative 10. I write it right here. And then I go ahead and add these two numbers together. So 13 minus 10 is 3. And then negative 5 times 3 would give me negative 15. I'm going to go ahead and add these two numbers together. I get a negative 1. Negative 5 times negative 1 is positive 5. And then when I add these together, I get 0. And that last number is our remainder. And then the final trick is that if our highest power is a 3, we just go one less than that. And then we're going to use that as our coefficient for that. So I'm going to go one less than that. It's going to be 2x squared. So we're starting with a squared, not x to the third. That's going to be one lower than the x squared. So that's going to be my plus 3x. And that's going to be my 1. And if you look back in the video, that was the answer to the first problem that we did earlier. Same thing over here. I would say to myself, well, if that's going to be my factor, my root would be x equals 2. And I'm going to use a 2 over here inside this little box here. And then I just carry down my coefficients. So I have a 1, I have a 2, I have a negative 8, a 5, and a positive 2. I'm going to go ahead and carry down my first leading coefficient. So there it is, 1. 2 times 1 is 2. Put it right here. Add these two together, I get a 4. 2 times 4 is 8. Add these two together, I get 0. 2 times 0 is 0. Add these together, I get a 5. 2 times 5 is 10. Add these together, I get a 12. And what do you know? That's my remainder that we just got a moment ago in the second problem. And then I start with using a power higher, one lower than this. So if it was x to the fourth, that's going to be 1x to the third. So there's my 1x to the third. And I'm going to say plus 4x squared. I would have x's next, but I don't have any. So I'm going to leave that part blank. And then I have a plus 5. And then because we have a remainder of 12, we'd say 12 over what we were dividing, which is x minus 2. And if you look back in the video, that was the answer to our second problem. So this is another way of doing division. It's called synthetic division. I happen to like it better. They both work great, so it kind of depends on what you're being asked to do, but both of them will give you the correct answers if the methods are used correctly. So I hope you got a lot out of this video, and hope to see you again soon here at Math Rocks with Mr. Cox. Thanks for watching.